This video gives an overview of the concept of number bonds and the technique of decomposing units in order to understand multiplication. What is a number bond? A number bond is a graphical way of representing multiplication as combining several groups of the same size together. For example, if we had 4 bags containing 3 apples, we could combine them all together into one box that contained 12 apples. Instead of using pictures of apples, we can simply write down the number of apples in each bag. Using mathematical notation, we can write this as 4 times 3 equals 12. We have 4 groups containing 3 objects each, and the total number of objects is 12. Sometimes this relationship is called a part-part-whole relationship. This strange-sounding combination is an extension of a part-whole relationship. The part-whole relationship simply says that you have a whole object, such as a bag of apples, that is built up from many parts, such as the individual apples. The part-part-whole relationship simply takes this one step further and says that the apples are part of a bag and the bags are part of a box. If you think about retail settings, you can see many applications of part-part-whole relationships or even part-part-part-whole relationships. For example, a single pencil may be part of a box of a dozen pencils, which came in a bundle of 20 boxes, which came in a crate containing 8 bundles, which came in a truck containing 15 boxes. How many pencils are on the truck? Another important conceptual consideration is that 4 bags of 3 apples and 3 bags of 4 apples are not the same thing, even though they are the same total number of apples. This type of thinking helps push students beyond the simple arithmetic and helps them to focus on larger ideas. Even though 4 times 3 and 3 times 4 may have the same value, they actually represent slightly different things. Instead of drawing out the apples in bunches, we can do it in a more orderly way by putting them into an array. An array is just a grid-like representation. Notice that by doing this, we draw a close relationship between the concepts of multiplication and area. In fact, we can use the concept of decomposing areas, that is, taking areas and breaking them into smaller pieces, to perform calculations. When you decompose an array of objects, you don't change the total number of objects. Let's separate out 2 sets of 3 apples from the group. This gives us a picture of 2 times 3, 2 groups of 3 apples, and another picture of 2 times 3. An expression that represents the total number of apples is 2 times 3 plus 2 times 3. This means 2 groups of 3 plus 2 groups of 3. Of course, this is the same thing as 4 groups of 3. The algebraic reasoning behind this is that we're counting the number of groups of 3. We can take this expression and write this as 2 plus 2 times 3. Notice that the number on the left is simply counting up the total number of groups of 3 that we have. This is a representation of the distributive property, and it's the same mathematical concept that leads us to things like 2x plus 2x equals 4x. At first, this type of regrouping seems to complicate things just for the sake of complicating it. However, young minds have not yet developed the same intuition that adults have. Rearranging and reorganizing information is not yet a natural idea, so it's important that they spend time playing around with the pictures to see how they fit together. As the class moves forward, the students will be pushed to keep reorganizing information like this in order to give them intellectual flexibility when it comes to thinking about situations. For example, number bonds will come up again, but representing different types of groupings. If we have 4 groups of 4 and 2 groups of 4, how many total groups of 4 will we have? This would give us 6 total groups of 4s. This is just the part-part-whole relationship once again. The quantities inside each circle can be represented with multiplication. Understanding these types of groupings in a concrete manner will make it simpler for students to understand larger groupings abstractly. For example, if we had 43 groups of 8, we can abstractly think about this as an array of objects. In this form, it is hard to immediately see how many total pieces we have. But if we break up the 43 into 40 and 3, the calculation becomes simpler. It's much easier to think about 40 groups of 8 and 3 groups of 8 than it is trying to think of 43 groups of 8 all at once. Remember that the goal of math education is not just to make students calculators, but that they would understand the ideas behind the calculations as well.